In today's lecture, we are going to start on Chapter 7. And Chapter 7 is one of my favorites. It is all about learning and adaptation. And so if you've picked up on it throughout the course, this is the part of psychology that I have actually done some research in. So I've been looking at communication in birds, but also in how they learn some of their communications. So in this chapter, we'll get to cover just a little bit of the research that I do, as well as the general learning and adaptation field. So to get started, we can start with our initial definition. So what is learning? This is going to be a process by which experience produces an enduring change in an organism's behavior or capabilities. So the parts that we care about here are that it's coming from experience. So learning happens because you are experiencing things. And this should make you think of our behaviorists who focused on environmental influences or experiences. We also care about the fact that these are enduring changes. It's not just, I did this once and now I'm going to do it again, but I'm going to forget for tomorrow. That's not learning. Learning is going to be a lasting or enduring change. So you do something and you learn from those outcomes, and we see it change your behavior from that point forth. And now it's important to note here that there's a little bit of a disconnect here between learning to do something and actually doing something. Now, in psychology, we can only really measure learning by looking at the behaviors that are performed. So changing behaviors is how we quantify learning. But you might learn how to do something, but never actually make use of that skill, which leaves psychologists at a little bit of a loss when we're trying to quantify whether you have learned something. So in humans, it's a little bit easier because you can just ask someone, hey, do you know how to X? Could you show me? But with animals, it's a little bit more difficult because we can only really ever say that they've learned something if we see that change in behavior. So a great example of this is songbirds, of course. When they're younger, they listen to their parents singing, and they learn to produce songs that sound like the songs their parents make. Now, there are some species that while they're learning from their parents, they're going to be copying right away. So they hear their parents sing, and then they produce their songs as close to the parents' songs as possible. And that's easy enough to measure. But in other species, they're going to listen to their parents sing, and they're going to store that information. So they're going to sit on that knowledge, on that potential learned song, and they might not use it until the following year when it's breeding season. So even though they might have learned to do something at one particular time of year, we might have to wait months down the line to see them actually making use of that behavior they learned. So this is a lot of making you aware of some of the restrictions that we have, where we can't necessarily know exactly when learning has occurred, but we can sort of make a best guess. So yes. All right. So for this chapter, we're going to be focusing on the big three of learning, which are three major types of learning that we can see. And these titles and names won't necessarily mean anything to you at the beginning, but at the end, once we've actually gone through all of these types of learning, it's going to make a little bit more sense. So we're going to start with event-alone learning, or habituation. So we're going to start with the simplest form of learning, and we'll cover that for sure today. We'll then get started on event learning, which is also called classical conditioning, or Pavlovian conditioning. And we'll start that today and then finish that up in the next lecture. And then we'll keep on later on in the week with behavior event learning, which is even more complicated again, and that's called instrumental or operant conditioning. And so we're going to spend quite a bit of time on each of these just so that you know how they all work and what the differences are between them. So, as promised, event alone learning. We're going to look at habituation and also the closely related sensitization. So, habituation is the process by which we respond less strongly over time to repeated stimuli. So, this is the idea of if the same stimulus is present for a very long period of time, you're going to respond to it less and less. Now, we've already talked about what we called sensory habituation. The idea of, we called it nose blindness, where there's a smell, and after a certain amount of time, you stop noticing the smell because you have habituated to it. Now, when we talk about habituation in terms of learning, we're going to frame it just a little bit differently. So, our sensory habituation was talking about the fact that we have sort of stimuli that we can ignore, or that we're no longer aware of because it's repetitive. So, a smell that we've gotten used to that we can ignore, or a sound that's happening over and over again that we're just not paying attention to. When we're looking at habituation as a form of learning, we're going to be specifically focusing on our response to that stimulus. So, because it's learning and we're looking at learning as a change in behavior, habituation as a form of learning will focus on that response, that behavior that occurs because of the stimulus. So, our habituation for this chapter is going to be focusing on that learning and changing, responding to a particular stimulus, whereas sensory habituation was specifically caring about sort of what we're paying attention to or what we're noticing. So just a slight difference in focus on very closely related concepts. So for habituation, this is something that was studied in a kind of unique model species. So I don't know that we've actually talked all that much about model species so far. Most of the time, when you talk about a model species, you're thinking of something like a lab rat or the common mouse, or maybe if you're into evolution and genetics, maybe you're talking about fruit flies. Those are all fairly common model species. But habituation was studied in the sea slug, Aplysia. And so these guys at the time weren't quite model species yet, but quickly became one because they have some pretty unique qualities. They have a very simplistic nervous system. They are not necessarily easy to house, but their nervous system is large, so their neurons are very big, and they're easy to identify and easy to manipulate, which is why a lot of behaviorists would then want to study this if you want to look at the neural stuff going on behind behaviors. And all of that is sort of extra stuff to say that when they wanted to study habituation, this was the ideal species because they had a very visible and very repeatable behavior that could be easily habituated. And that behavior is called a gill withdrawal reflex. And so what happens with these sea slugs is they have this gill on the side of their backs. So there's an opening where they can stick out their gills, and the gills is how they breathe. And so these gills are soft and delicate, so they're very sensitive to being damaged. And so in the wild, where these guys would be on the coastline, if they get hit with waves, if there's particles thrown up, if there's lots of debris and stuff hitting their gills, their reflexive action is to pull their gill back inside where it's protected. And somehow scientists realized that they could make use of this because if you poke a gill, if the sea slug is sitting there and you poke their gill, they will draw their gill in very, very quickly. So if you sit there for a very long time with a stick and poke this slug's gill, eventually it will habituate, which means that that withdrawal action will become less and less. So if we scoot back here, so responding less strongly over time to repeated stimuli. So as you poke them over and over again, they don't respond as vigorously and they don't respond as quickly, and they go back to normal. They'll put their gill back out a lot faster than they would at the beginning. And so this change in behavior can actually last quite a long time. Under proper conditions, you can see them change their behavior for hours or even days. So this behavior then counts as learning because we're seeing this prolonged change in behavior that comes from experiencing this repeated gill poking. Another example that is commonly looked at for habituation is something called a startle response. And so a great example of this that I experience fairly often where I live is that sometimes your building is going to test the fire alarm. And sometimes they give you warning, sometimes they don't. But at the beginning of the day, the first time your fire alarm goes off, that's something that is designed to grab your attention. There's flashing lights, there's loud sounds, it's abrupt, and you're going to jump. So that jump is your startle response. You have been startled by an external stimulus. So that happens at the beginning of the day. You jump really bad. It's awful. The fire alarm goes off again, say 15 minutes later, you're going to jump again. But when it goes off every 15 minutes for maybe an hour, then maybe you're getting used to it. You're still going to notice it. And you might still jump, especially if you're like me. But over time, you're going to get used to that sound. You still notice it, it's still there, but it causes less of a startle response. You have habituated to that sound. And on the next slide, I have a link to a YouTube video that shows this habituation of a startle response in rats. And so what it shows is a rat in a cage, and they play a very loud, startling sound, and the rat the first time will jump and freeze, and then over time, that freezing response becomes less and less, and it's showing that that behavior response to a loud sound has changed as the animals habituate to that sound. And as per usual, that video is on our e-class. Now, you might be thinking, okay, with the fire alarm example, so you might be getting used to it. You might stop jumping because it's, you've habituated to it, you've gotten used to it, you have less of a startle response. But sometimes stimuli go the other way. Sometimes you're just going to end up with a headache. Maybe the sound gets worse because it's repetitive. Maybe you've experienced that. And there is actually a counterpoint to habituation called sensitization. And so in this case, it's almost doing the opposite of what habituation was. And so with sensitization, you see an increase in the strength of a response to a repeated stimulus. So that with our example of the fire alarm going off, maybe you're someone who's prone to migraines, or maybe you're someone who's jumpy by nature. And then every time the fire alarm goes off, it actually makes you more tense and you get more worked up. Maybe your head starts hurting. But now, every time it goes off, it's worse because you've gotten worked up about it. So you can have sensitization to the exact same stimuli that you have habituation to. It just depends on a bunch of other conditions. So this can happen just because of repeated presentations of a particular kind of stimulus, or there could be something about arousal from other stimuli going on. So maybe you're worked up because most days you could habituate to it and come to ignore it, but today you're already on edge because you watched a scary movie last night, or something like that. So your internal state can also affect whether you are sensitized or habituated to a particular stimulus. And there are some stimuli that are, more likely to have you sensitized to them versus habituated to them, but it's not always the case. You can have both to the same stimulus under the right conditions. And so if we wanted to look at what this might look like graphically, so here we actually have an experiment that was done with the startle response for rats. So how much are rats jumping in response to a loud tone? And here they varied some other environmental stimuli, specifically the background noise in their cage. So first, we're just going to look at this side of the graph, and this is with 60 decibel background noise. And if you remember back to our chapter talking about specifically our hearing and audition, 60 decibels isn't all that loud. It's loud enough, but it's not terrible. And so here at the bottom, we have blocks of 10 tones. So this is basically their equivalent of time. So how many times they have played this loud sound at these rats, specifically in a moderate background noise condition. And so at the very beginning, right off the bat, when they first expose this rat to these loud tones, they jump a lot. And they're quantifying this as startle magnitude, which I'm not quite sure how they're quantifying how much a rat jumps in response to a particular sound, but that's what it is. And so we have here, they have pretty big startle response. But as time goes on, as we go through more and more exposures, that magnitude of startling adjusts. And so pretty quickly, the amount that these rats are jumping anytime that tone is presented drops off pretty dramatically. So here we see habituation because they are responding less over time to the presentation of stimulus. Now, if we move to the other half of the chart, it's the same thing, startle magnitude by time, but this time with a background noise that's a little bit louder. So this time 80 decibels. And 80 decibels is pretty darn loud. This is where it's hard to hear other things around you. And so what's happening is in this loud environment, when they play these tones, at the beginning, the rats aren't overly startled. But over time, each time they're presented with these tones, their magnitude of responding, how much they jump, gets larger. They're becoming sensitized to the sound because of the change in environmental conditions. And so my thought here would be that in a loud environment, it's really hard to hear a predator or something sneaking up on you. So it makes sense to get more and more on edge because you can't hear potential threats. So when these tones come out of nowhere, they're very startling because you couldn't really hear anything coming. Whereas over here, when the sound was a lot less, you weren't as on edge because of the background noise. And so you could habituate. Whereas here with the loud background noise, you are sensitized. And then overall, when we're talking about habituation, it's usually very specific to the exact stimulus that you are seeing or hearing or feeling. So if your fire alarm is going off and it's always the exact same pitch, it's always the exact same loudness, you could habituate to that. But the second it changes, maybe this time the building next to you's fire alarm goes off and theirs is a different pitch. That would startle you because it's different than what you had habituated to. In contrast, for sensitization, if you're already on edge and you're jumping out of your skin every time your own fire alarm goes off, when the neighboring building's fire alarm goes off, you're still going to jump. So you can habituate to a specific stimulus, but once you become sensitized, you're usually going to generalize that and apply it to non-specific stimuli. And that's most of the time, not always. All right, so that was habituation and then into sensitization. So That was event alone learning. I brought this slide forward so we can start picking apart what these titles are meaning. So, we're talking about event alone learning. That was basically just we hear a stimulus and we learn and change our response to that stimulus. So, we cared about a single event and nothing else. So, that's where habituation comes from.